Okay, gang, I'm going to show you how to factor by grouping. So this method is a dead giveaway that you use this method whenever you have 4 terms. Okay? Okay, example 1. What you do is you look to see what the first 2 terms have in common. So let's go ahead and let me use red. And the first 2 terms have a 3x in common. So we take out a 3 and an x, and then we see what's left. So we know that we need to multiply by 4x plus, and then 3x times something here gives me 3x, so I have to multiply by, I have to put a 1 there. And then now I'm looking to see what the last 2 terms have in common. So it looks like they have a -2 in common, so I'm going to take out a -2, and then I'm going to see what I need to put in parentheses here so that I get the same thing back again. Now, of course, you can kind of peek over to the left and see that it's supposed to be 4x plus 1. So you can put that in there if you like and just make sure that that's exactly right. So this would be -8x, and then this would be -2 if you were to distribute. Now we notice that they're both 4x plus 1, so we take that out. We factor it out of both terms. And then when you take that out, you can see that there's a 3x left over. And then out of the second part, there's a -2 left over. So then put an extra set of parentheses there, and we're done with that first one. Alright, example 2. You want to look to see again what do the first 2 terms have in common. So they have a 2 in common, and they have a s in common. So we factor that out, and then we see what's left. There would be an s left over plus 1. Then the last 2 terms, they have a 3 in common, so we take out a 3, and then that leaves us with s plus 1. We notice that s plus 1 is in common with both of these terms, so we take out an s plus 1, put a set of parentheses, and then we have 2s plus 3, and that's it. The next example, example 3, we want to see what they have in common, so we look to see, we notice that they have a 3 in common as well as an x, so we take that out. We have to multiply by 3x to get the same thing back again, minus y, and then we look at the last 2 terms and see what they have in common. Looks like they have a 2 in common, and then what's left would be 3x minus y. Notice the 3x minus y in common between the 2 terms, so we can take out the 3x minus y, see what's left. We have the 3x left over plus 2. And that's it. That's really a factor by grouping. Again, it's only for polynomials that have 4 terms. And that should do it. Oh, I say now you do one? Well, I'll do one more. You go ahead and do it, and then pause the video, and then you can check it, see if it's right. So we got, for this one, we have a 4b in common, so we take that out and then see what's left. And then the next 2 terms, we have a 2 in common, and then we see what's left, so b minus 3 is left. And then we notice that b minus 3 is what they have in common, so we take that out. And then we have 4b, whoops, we have 4b plus 2. Now actually this one is not completely right. because before we even do this problem, you're supposed to take out the GCF. So this is factored by grouping for sure, but you'll notice that these still have something in common. They still have a 2 in common. So probably we'll do this one. I'm going to do one like this a little bit later, but for right now I'm going to say it is factored by grouping. It's just not factored completely. You would actually have to take out a 2 just out of these last two terms, and then it would be b plus 2. So then at least it would be factored completely. You should put the 2 on the outside, but at least everything's at least factored out. Okay? Alright, should be good enough for now.